All right, we are doing prep for tomorrow's exam. I know it was a really quick turnaround, but this is what we all talked about. We did our practice interim assessment blocks on the computer. We went over some of those questions, and then these are the type of questions that we see for tomorrow's exam. All right, for this guy right here, just so you guys know, for your exam tomorrow, it's going to be half multiple choice and half free response. You're not going to have to draw any pictures like this. The pictures will already be given to you. Yeah, it's part of your grade. This is the exam that we were. It should be part of your grade. The one that you guys took for the computer part was not. That was just. So I'm going to draw this picture for you guys. Let me zoom in a little bit so you guys can see. All right, a guy is flying a kite. So here's the guy. There's the kite string. And it is 201 meters of string. There's the string. And then the kite's kind of up here. There's the kite. The angle of elevation with the ground is 40 degrees. How high up is the kite? So they're looking for this height right here. That's what they want. Right. There's no reason you should fail this exam. It's trig ratios and congruency. So it's literally what we've been doing the whole time, just with multiple choice options. And so it's literally the same stuff. It's more trig ratios. Here we are again with trig ratios. All right, so I'm here. I'm looking for the height. I have opposite over hypotenuse. Opposite over hypotenuse, which is sine. So I have sine of 40 equals x over 201. I need to get x by itself, so I'm going to multiply both sides by 201. And I get 201 times the sine of 40. So on my calculator, clear that out, I've got 201 times sine 40, which gives me 129.2. Now, what did I just find? I just found this height. So this guy right here is that height. My answer makes sense because my hypotenuse is going to be the longest. So this guy right here should definitely be shorter than that. All right, so same kind of deal, trig ratio again, no problem. Number 2. Mark the part needed to prove congruency. So I have a side and an angle. If I need to make one mark to make them congruent, the easiest thing to do is to mark right here. This guy right here. This guy right here is going to make it reflexive so that this little triangle and this triangle are congruent. This is your best bet. This is the easiest way to look at this. So this one right here, reflexive, it's congruent to itself. That's how I would have marked that. What theorem can be used? So which one can be used to prove it? You have 2 choices for this one. You have side, angle, side. So there's your first one, side, angle, side. Or because this has a right triangle right here, you can use, oh, no, sorry, you can't use hypotenuse leg because there is no hypotenuse. So with the right triangle, if these were congruent, you could use hypotenuse leg. But for this one, it has to be side, angle, side because you're not given the congruent hypotenuse. So just kidding, just one choice. All right, and then angle ABD. ABD, that is this angle right here, this guy right here. Which one is he congruent to? He's going to be congruent to this little piece right here, which is CBD. Angle CBD. So these guys right here will be congruent. These questions like this are on your test. There is a question like this about this. I think it's like a bow tie type of problem instead of a triangle like this, but same kind of idea. Mark something to make it congruent. In this case, if you do get a bow tie problem like this, remember vertical angles. Always remember vertical angles. All right, this guy right here. The height of the tree is 57 feet. So right here is 57. What is the measure of x? They're looking for an angle. So when you're looking for an angle, remember you're going to use inverse sine, cosine, or tangent. So you're going to have to use one of those. And if I'm here, I have opposite over adjacent. I'm not given the hypotenuse in any way. I have opposite over adjacent, which is tangent. All right. So because I'm looking for an angle, I know it's going to be inverse tangent is equal to opposite over adjacent, 57 over 15. So here we go. For the vertical angle is the same. It just depends on what else is given if you're looking up here, but just remember to mark that these ones are always going to be congruent for vertical angles. So it's just an easy way to say, oh, if they've already given me 2, that's an easy third. All right, finishing here. Second, inverse tangent. Remember, that's how you get it. You go second and then that function, 57 divided by 15 gives me a grand total of 72.5. I'm sorry, 75.2. Sorry, it's reversed when I look at it. 75.25. And what you just found is the measure of that angle. So that guy's there. All right. And on your test, like I said, some of these are going to be multiple choice. There is an error analysis on your exam tomorrow. So a question like this, it's, circle the error and then resolve it to get the correct answer. So what I would do here is you would need to distribute first. Once I distribute, I have negative 2 times 8m gets me negative 16m. And then negative 2 times 8. Here's where the big mistake is. It's right there because that should have been negative 16. So there's my first error. Everything else is wrong after that error. Yes, they made multiple errors within this, but let's rewrite the problem so that we can resolve it and get the correct answer. I'm going to distribute, which gives me negative 16m minus 16 equals negative 16. I'm going to add 16 to both sides. Negative 16m is equal to 0. Right? I'm not done yet. Divide both sides by negative 16. You want to get m by itself. And m is equal to 0 over negative 16, which is just 0. Remember, a 0 on top of a fraction is just going to be 0. So in this case, m equals 0. All right, this guy right here. So there's a question like this on your exam tomorrow, and just to be aware of the way that they ask these questions, SBAC it's sometimes a little tricky the way they ask questions. So this one says select all equations that can be used to find x. All right, so when you're looking at this, I'm looking for an angle. So obviously in my head, I should think, okay, let me use some kind of inverse. All right, but if I'm just starting right off the bat, I'm looking for this guy right here. Sine of x equals 12 over 15. If I wanted to find the sine of x 12 over 15, all right, sine of x equals 12 over 15. Technically, that wouldn't work. I would need to divide out by sine, which is going to get me the inverse sine. So depending on how this is phrased, if it says to select any equation that might be used to further solve, technically you could use that one, okay? Because you would just need to divide both sides out by sine, which would then take you to here. This is just one step further than this. But remember, inverse is what you're always going to want to use to find a variable. Inverse sine 9 over 15, that doesn't work at all because 9 over 15 would not be sine of x. That would be adjacent over hypotenuse. So this guy is no good. All right, the cosine one, this is a little tricky too, depending on how the question is worded. But I could use the cosine of x to find this. I would just need to divide out by the cosine, which would then get me here. So do you guys see that this is one step before here? So this one and this one would work because I have adjacent over hypotenuse. And then tangent also, all right? But just so you guys know, when you put in your calculator, you're always going to want to use the inverse one. It's going to be easier. Otherwise, you're doing multiple steps. But like I said, on your exam, there is a question like this with a guy and a ladder and a house. And I actually think all your options are written without an inverse. So you're going to have to pick which ones work best. But technically, when you're given all three sides like this, any of them will work. So you can pick tangent. You could go opposite over adjacent. You could pick sine, opposite over hypotenuse. You could pick cosine, adjacent over hypotenuse. Any of those will work when you're given all three sides. So that guy's good too. All right, I like this question. This question was kind of on your last exam that we went over. And it says, what is the ratio that is equivalent, there's a good word, it means equal, to sine B? All right, so here I am on sine B. The easiest way to do problems like this, I think, are to actually just throw in some numbers just to see if it works. And I'm a big fan of just 1, 2, 3 or whatever. Just like I said, you're not solving anything. You just want to see what ratio is equivalent to the sine of B. So if I was to do or 3, 4, 5, that's an easy triangle to do. What's sine of B? Sine of B would be 3 over 5. Sine of B equals 3 over 5. Well, what other thing equals 3 over 5? If you look at it, the other thing that equals 3 over 5, if I'm standing here, is the cosine of A. The cosine of A is 3 over 5. So when I ask you a question like this, what is the ratio that is equivalent to sine B? It's the cosine of A. And I know we went over that a lot last week when we did the trig ratio exam. Remember, the sine of one angle is the cosine of the other angle, and vice versa. Sine of A is 4 over 5. Cosine of B is 4 over 5. All right. This guy right here. Which transformation would not change the size of the original figure? All right, so we've got 4 choices for transformations. We've got translation, dilation, reflection, and rotation. So which one would not change the size? Right, there's more than one answer. The only one that changes the actual size is the dilation, okay? This one changes size. So that translation, reflection, and rotation would not change the size. Translation, remember, is just picking up, it's literally moving it from here to here. I just went from there to there. There's my prime. Reflection, you're not making it bigger or smaller. There's no midpoint in distance on the exam. You're going back and forth, no problem. Rotation, same shape, just spinning it around. Dilation is the only one that makes it bigger. So which transformation would not change the size? Any of those 3 are not going to actually change the size. So to answer your question, Victor, no midpoint and no distance on the exam. The only way we would use distance is if it was a Pythagorean theorem question. So when you look at a question like this, where they want height or distance or things like that, or like if they wanted something like this, where they wanted the distance from here to here, you would use Pythagorean theorem, but it wouldn't be the distance formula. All right, this guy here, let me go this way. Draw a triangle ABC where B is the right angle. A, B, C, B is the right angle. If the sine of C is 1 over 50, what is the cosine of A? All right, so sine of C, opposite over hypotenuse. Cosine of A, it's the same. Remember, this goes back to the same question that is right here. The sine of one angle is the cosine of another. So this guy right here, the cosine of A is just going to be the same one. It's still 1 over 50. The sine of one angle is the cosine of the other. And then this guy right here, I know if you guys were given this one and you're not in my class, I told them this is not drawn to scale. As you can tell, I just freehanded this. So not drawn to scale. And I basically told them all the figures are the same size, even though they don't look it. But that's what happens when you freehand things. Okay. So describe the transformations. How did I get from here to here to here? And you have to know where to start on a question like this. So I know to start, with this guy right here. This guy's my number 1. This guy's my number 2, and this guy's my number 3. And I know that because of the way the primes are labeled. This one has no prime, so he's my original. This guy's got 1. This guy's got 2. So this is my original. Here's my first translation or transformation, and here's my second transformation. So you have to be able to recognize it on your exam tomorrow. All right, going from here to here. Now, like I said, I know it looks bigger, but they're not. If I just went from here to here, I just translated it. I picked it up and I moved it here. I took this piece and I just said, here you go. So my first one from 1 to 2, I translated. If you had numbers given on here or they actually put points, you could tell me how many you translated. So I translated it up however many and over how many. And then how did I get from here to here? I rotated. And which way did I rotate? I rotated it that way, which would be clockwise. Okay. This, like I said, this was a short review sheet. I know some of you guys got different review sheets, which is fine. But again, 50% of your exam tomorrow, at least, is going to be multiple choice. So questions like this, they're not all going to be free response like I had them on this review sheet. It's going to be the trig ratios is a big thing. The congruency. There is one proof. There is a lot of transformations. And there is triangle similarity. And I believe actually there is one parallel line question. Parallel lines with the transversal. All right. A proof. What do I mean by a proof? So a proof would be, I'm going to cover that up real quick for you guys. A proof would be something like this. And A, B, C, D, E. And it's where you do the 2 columns and you have the given. So you have your statement and your reason. Statement, reason. And it'll ask you it'll give you some kind of information. So given, and then it'll want you to prove that triangle, let's see, AEC is congruent to triangle BEC. So that's what the proof is. I know you guys have done plenty of those things, depending on what's given. So they're going to want you to actually write out those reasons. So that's a proof. I can make something up. So if I just say angle B is congruent to angle C, and let's go with CB bisects AD. All right, so if that's given, I can say that this angle is congruent to this angle. That's given. I would write it here. Angle B is congruent to angle C. I know that because it's given. I can say CB bisects AD. So that's going to make this piece and this piece equal. So I'm going to say AE is congruent to ED, and that is because of the definition of bisect. So I can mark that. And then here's where your vertical angles one comes in handy. I can say that angle AEC is congruent to angle DEB because of vertical angles. Vertical angles are congruent. And then I can say that triangle AEC is congruent to triangle BEC because of angle, side. Right, that's a proof. It doesn't have to look like that. It can look like this one. They can tell you, you know, prove this one. I could have just given you these two, and you could have proved it by angle, side angle. If they give you this outside one right here, it could have been hypotenuse leg. So that's what it means by a proof. I know it's super short review, but like I said, it's a super short test because you guys have done tons of this right triangle stuff, tons of congruency. And so if you need extra help tomorrow at lunch, I can help you at lunch in 110. So if you guys want tutoring at lunch, I'll be in 110. Here is what is going to be on the test again. So tutoring at lunch tomorrow in 110. If you want tutoring before school, I know Finch is usually there pretty early in 107. I know that sometimes Arno is there pretty early, and I think he's in 151. So if you need tutoring, like I said, we can do this. This is with me. You guys want to come for tutoring at lunch, and you have geometry 3rd or 4th period, I can help you guys out with that stuff too. All right. Good luck on your exam tomorrow. Your next exam will be a week from Friday, and your teachers will let you know tomorrow when you're going to be retaking your previous exam. So there will be retakes again to help you guys out with your grades.